I welcome you all for the topic of basic circuit analysis. I am Monisha, working as an assistant professor in the Department of Electronics and Communication Engineering from the College of Kalana Karnanidhi Institute of Technology. Basically, circuit analysis is used to predict the behavior of an electrical circuit and plays a key role in design process. So, circuit without a circuit analysis, we can't design a circuit. For example, we are having a laptop, isn't it? So, we have a lots of devices, circuits, chips. So, that chips has been designed with the help of the circuit analysis. So, basically, circuit analysis we need a voltage and current. So voltage are the and current are the two fundamental concepts in a circuit analysis. What is meant by voltage? Voltage is a potential difference between 2 points in a circuit, while current is a flow of electric charge through a conductor. That is, the relationship between voltage and current can be described with the help of a Ohm's law. Ohm's law states the relationship between electric current and potential difference. So look at this circuit. We can find the value of voltage, current, and resistor. That three devices has been connected in a single battery. These three devices has been connected in a single battery. This devices has been named as an Ohm's law. With this, we can find the values for the Ohm's law also. Ohm's law can be mentioned with the help of the formula V is divided by I into R. That is, it can be split into three formulas also. That is, voltage is equal to current into resistance, and current is equal to voltage divided by resistance, and the last resistor is equal to voltage divided by current. Voltage can be determined with the help of the unit of voltage is watt, unit of current is amps, unit of resistance is ohm. Let's see the example based on Ohm's law. That is, look at this question, simple question based on a voltage. We have a simple electric circuit with a battery and a resistor. We don't know what voltage the battery is though. So the resistor is 3 ohms. They mentioned that resistor value is 3 ohm, and when we connect a multimeter into 2 amps, multimeter into 2 amps, so they are mentioned 3 ohms, 3 ohm resistor, and the multimeter value is 2 amps. Multimeter value is 2 ohms and 2 amps, and the resistor value is 3 ohms, and they mentioned that they want to calculate the value of voltage. What's the formula to calculate the voltage? V is equal to I into R. That is, voltage is equal to current into resistance. Current value is 2 amps and resistor value is 3 ohms. 2 into 3 is V is equal to 6. So the value of voltage is V is equal to 6 volt. Another example to calculate a current. So the formula to calculate current is I is equal to V divided by R, isn't it? V divided by R. Here they have explained the sum also. Let's say we now have a 3 ohm lamp connected to a 6 watt power supply. To find the current, we write down I and cover up the I in a triangle. That gives us V divided by R. So current equal voltage divided by resistance. We know the voltage is 6 watt and the resistance is 3 ohms. So the current is therefore 2 amps, and that's what we have mentioned here. That's what the current value is has been given. So we know the value of resistor is 3 ohms and the value of voltage is 6 watt, and we have to calculate the value of current. V is equal to I in V value of current. I is equal to V divided by R, that is voltage divided by resistance. Voltage value is 6 divided by 3. 6 divided by 3 means 2. The value will be 2. So we can find the values I is equal to 2 amps. So we have another example for resistance. We have a resistive lamp connected to 12 volt power supply. We don't know how much resistance it's adding to the circuit, but we measure the current in 0.5 amps. So resistance value is question mark, current value is 0.5 amps, and the power supply voltage value is 12 volt. So the formula to find resistance is R is equal to V by I. R is equal to V by I. Resistance is equal to voltage divided by current. Voltage value is 12 and the current value is 0.5 amps. 12 divided by 0.5, the value of resistance is 24 ohms. 24 ohms. Here is another part of a circuit analysis. It's a Kirchhoff's law. Kirchhoff's law or fundamental principle used in circuit analysis to determine the flow of current and voltage within a circuit. Here they have mentioned the flow of current and voltage within a circuit to measure the voltage and current. The next we can go for a Kirchhoff's law. Kirchhoff's has two types of law. One is Kirchhoff's current law and another is Kirchhoff's current law. Kirchhoff's first law states the Kirchhoff's current law, that is, current entering the node will be equal to the current leaving out of the node. Current entering the node will be equal to current leaving out of the node. Here they mention that current entering I1, I2 and I3 are current entering into this node, and current leaving is I4 and I5 will be equal to current leaving out of the node will be equal to 0. That is, with the help of this equation, we can identify that I1 plus I2 plus I3 minus of I4 plus I5, that is equal to 0. We can next on this next stage we can differentiate that I1 plus I2 plus I3 will be equal to I4 plus I5, that is current entering a node will be equal to current leaving out of the node. Kirchhoff's second law states that the algebraic sum of a voltage in any closed path of a network is 0. Here, for an example, we can notify this circuit is a closed path. Closed path, the algebraic sum of a voltage in any closed path of a network is equal to 0. That is, the sum of the network means adding all the values which is connected in that network, that value will be equal to 0. That value will be equal to 0. So we can differentiate this in another step also. The algebraic sum of all the EMF and the algebraic sum of the voltage drops is equal to 0. Algebraic sum of EMF and algebraic sum of voltage drops will be equal to 0. That is, V is summation of E plus summation of V is equal to 0. To identify voltage, V is equal to IR will be useful to calculate current voltage value. So here we have two laws. One is Kirchhoff's voltage law, another one is Kirchhoff's current law. Next one is types of circuit. It has three basic types of circuit. One is series, parallel and combinational. Combinational in the sense is a combination of parallel and series connection. Combination of parallel and series connection. Here is a circuit diagram we can which can we understand about a parallel and series, difference between series and a parallel. That is, in a parallel connection, here we have a different bulbs that is connected in a parallel connection. Then here we have mentioned that different bulbs connected in a series connection. Different bulbs connected in a series connection. For example, one bulb is connected with that rope, another bulb is connected with that rope, another bulb also connected. They are controlled within a single switch. If the switch has been switched off, the entire bulb will be shutted off, and the switch has been on, the entire bulb will be switched on. That is what mentioned in a series connection. In a pair connection, we can take even a single bulb and also a second bulb also. If we want only a single bulb, the single bulb connection get turned on. If we don't want another bulb, the another bulb connection can be cut off. This is what used in a parallel and series connection. Clearly about series, parallel and the combinational connection. Here is a diagram and also a values to calculate about a series connection. So first denotes about a the series connection. The formula to calculate a series connection is R is equal to R1 plus R2, and the parallel connection is parallel connection. The formula to calculate about parallel connection is R is equal to R1 into R2 divided by R1 plus R2. The combinational circuit, they denotes a combination of parallel connection and the series connection. So both the formula, both formula, that is parallel connection formula and series connection formula, both has been used in a combinational circuit. Finally, we came for the conclusion of the basic circuit analysis. By understanding the fundamental concepts of circuit, the different types of circuit and the various techniques used in circuit analysis, engineers can design the following techniques. They are electronic devices, troubleshoot electrical problems, and optimize power consumptions. That is, there are they knows the values not only for the theoretical concept, they can have a practical experience also with the real world applications. That is, for example, in a ship, there is a two types of connection. The entire ship of internal connections has been connected in a series connection. The entire ship's external connection has been connected in a parallel connection. And in this internal connections, if one switch is in a control of all interior switch integration, there will be a 3 or 4 controllers used in a parallel connections, because it's a parallel connection, isn't it? We can take one side of circuit or else another side of circuit. So the entire connections will be connected in a 2 to 4 connections in a external connection. If one switch has been shutted off in a external connection, there 3 connections will be blinking on. But whereas in a series connection which has been connected in a internal connections, if one switch has been shutted off, the entire power supply will be shutted off. That is a real life example for this circuit analysis. As the technology continues to advance and new chances arises, it is important for engineers to continue learning and applying these concepts in their work. That is, engineers will be learning again and again to develop upcoming a daily life process, and this work will be useful for us to get an advanced technology as like that. This what the concepts and technologies used in basic circuit analysis. Okay, thank you.